made significant strides in recent decades. Effective colonization options remain quite limited, mainly due to technological restrictions and the extreme conditions found on other celestial bodies. In this context, Mars has always stood out as the prime candidate, since multiple space probe missions that landed there have found hints of frozen water and futuristic that at some point it might support life, even if in a very challenging way. However, before betting our chips on such a remote destination, perhaps we should look at closer targets and evaluate their potential for habitability or scientific. After all, the moon or natural satellite is much more within our reach, which could bring logistical and technological advantages that would allow us to test on a smaller scale elements and strategies for living off our planet. Imagine for a moment the opportunity to live on the moon. You would have an unparalleled view off planet Earth, almost like a cosmic postcard, with every sunrise. Moving around in an environment where gravity is significantly lower would add a touch of adventure to everyday life, turning simple actions like walking or jumping into memorable experiences. In addition, a lunar resident's daily life would be like that of an explorer. Instead of streets and buildings, there would be craters and rugged terrains waiting to be studied and documented. The idea of establishing a base on the moon goes back to old projects and centuries-old science fiction tales, but it gained real momentum after the Apollo missions, which culminated with the historic landings in 1960s and 1970s. Seeing astronauts set foot on the lunar surface proved that our natural satellite could indeed be reached and studied directly, paving the way for the concept of permanent stations. And if we consider thus the issue of distance, the becomes even more attractive. The moon, about 211.0 miles from Earth, whereas Mars at its closest point remains around 33 million miles away. This vast difference means that in theory the logistics of creating a lunar colony much simpler compared to mounting a manned mission to Mars. Yet distance isn't the only decisive factor. Besides being closer, the moon also offers communication advantages. Because it's so near, the delay in sending and receiving signals is much shorter than it would be with Mars, directly affecting our ability to control robots, rovers, and other technologies without long wait times. This proximity would also make it easier to deliver basic resources, which could be transported from Earth more frequently and at a relatively lower cost than a trip to the Red Planet. Ultimately, these circumstances positioned the moon a true testing ground for survival, habitation, and resource extraction technologies, providing the scientific and practical foundations needed for even bolder missions into deep space. Despite the benefits of binary living on the moon poses enormous challenges. Although companies like SpaceX and Blue Origin are investing heavily in lunar exploration, their main goal is resource extraction, such as gold, silver, and titanium for trade back on Earth, not turning the satellite into a second home for humanity. These resources found in abundance on the lunar surface open up as abilities for new production chains and economic development, but everyday life in such a hostile environment still seems far off. One of the biggest hurdles for successful lunar colonization is the lack of a robust atmosphere. While Earth is enveloped by a layer of gases, mostly made up of 78% nitrogen, 21% oxygen, and small amounts of carbon dioxide, water vapor, and argon, that acts as a protective shield against solar radiation and other cosmic dangers. The moon's atmosphere is extremely thin. Without this natural filter, any unique exposed to intense solar radiation with a proper protection would see their cells and DNA compromised in just a few minutes, forcing inhabitants to rely constantly on heavy space suits to serve. Moreover, the moon's thin layer of gases can't dissipate the impact of asteroids like Earth. Just on the moon, smaller objects aren't completely destroyed before hitting the surface, which explains the abundance of craters in our natural satellite. Another critical factor is the scarcity of liquid water. Although ice caps are found in permanently shadowed regions near the lunar poles, these areas are so cold that water remains frozen. To obtain water in liquid form, the ice would have to be extracted and transported to areas with milder temperatures, a process that involves significant technical and logistical unless extreme temperature fluctuations also present a considerably during the day. Lunar surface temperatures can reach about 248 while at night they can plunge to minus. This disparity creates an environment similar to an extreme desert requiring GAD and thermal regulation systems to maintain habitable conditions. Another delicate issue Iceland just formed over billions of years from micrometeorite bombardments and highly electrostatic. It tends to stick to any surface it contacts. Its abrasive texture can wear down, damage, and clog crucial parts of equipment and vehicles, as well as irritate the skin and eyes of astronauts. Even with protective guard, this abrasive quality not only harms mechanical systems, potentially causing gear failures or component overheating, but also complicates cleaning and maintenance, demanding specialized designs. To prevent dust buildup from compromising the operation of habitation modules, life support systems, and other vital equipment, it's worth noting that even the brief periods of activity by Apollo astronauts showed just how persistently this tiny dust could infiltrate everything, making it a key chilling in any long-term mission on the lunar surface. Food and agriculture in a lunar environment would also be no trivial matter. Currently, astronauts' diets consist of dehydrated and easily preserved foods, but the moon's soil, known as regolith, unsuitable for traditional cultivation since rapid root erosion and the presence of metals and toxic compounds hinder healthy plant growth. The solution lies in implementing cultivating techniques like hydroponics. Plants grow in nutrient-rich water, though this would require the development of specific infrastructure to protect crops from intense solar radiation. With so many challenges, complementalization of the moon might not be the best long-term option for human life. Instead, the moon could serve as a strategic base, a staging point for future interplanetary expeditions, acting as a supply and logistics hub for missions toward more promising destinations, such as Mars. While not the ultimate solution for human expansion into space, establishing a lunar base could represent an important technologic and scientific breakthrough, paving the way for new discoveries and improving TechnoQuest might eventually enable the colonization of other planets. Even though the moon offers some logistical advantages, Mars still appears to be the destination with the greatest potential for creating permanent habitats. Even if Mars has its own challenges, starting with the distance, nonetheless turning the moon into a strategic base for space travel might be a crucial step toward one day helping humanity reach new horizons in the universe. If you love the mysteries of the universe, feel free to subscribe to the channel, like this video, and turn on notifications. That way you won't miss any news about our space journey and the advances that take us ever farther. Thanks for watching. See you on the next Moon Day in the Space World 3/5.